update video on the transmitter. Here's the new design, how good it looks. This baby can handle 100 watts now. All the components are upgraded. I'm probably going to work out a few more details and then sell these as little kits. The end product would probably have a bigger heat sink, probably 3 times this size for heat dissipation. That way it doesn't have to sit in water. I mean, I could take it out of the water right now, but it would get too warm for comfort. I mean, you got 100 watts coursing through this thing at full power. You want to have a huge heat sink. There's the big transistor. I showed that in the earlier video, and it will be in this video's description. I put all these connector blocks and everything, made the circuit look really clean and nice. Beefier diodes. Everything was beefed up. And yeah, this is only a 1/4 inch now, primary. Secondary is 4 inches long, and the top load is 1/2 inch. So 1/4 inch, 4 inch, 1/2 inch. And this is just a top load. This is a shorted coil connected to the output of the secondary. And we got this diode pickup chain thing again. Literally just those diodes that I showed in the earlier video, taped to a pipe. Little capacitor on there to hold more of a charge. Literally just a diode chain capacitor, and you ground the center. I showed that in earlier videos. And I'd also like to give a huge thank you to the members who are donating to the GoFundMe. You guys know who you are, and I'm giving you a huge thank you. Great gratitude. My end goal with this technology is to perfect this design and sell it as a kit so it can be mass produced and people can do mass experiments with it with energy from the ground. And we got that thing over there. That wireless light that will light up once I turn the transmitter on. And there's something beautiful about mathematics and precise electrical engineering. Check this out. Transmitter on. Ba-boom. It's getting perfected, guys. It's getting there. We're almost close to a product that can be sold. Like, the range is incredible. This is an anti-arc discharge Tesla coil, solid state. A real one. None of those wasteful detuning sparks. You want sparks? This thing isn't for you. This is a well-tuned coil, capable of doing many things. I might include this diode chain with the kit too, and a special ground wire. I'm not sure what I'll include with the kit yet, but slight more refinements have to be made. I'll include a few coils that you can plug into ground and they'll light up with LEDs. And look how bright that is. Little explanation of how it works. And using this big Russian chip, I mean, you're pretty much never going to blow it unless you act really stupid with the thing. It's a 2SC3264 transistor. I think it can handle like 6 amps on the base, so you don't need much of a resistor to protect the base. Maybe like a 22K to a 50K. The collector outputs 17 amps, and the emitter outputs 230 volts, I think. Pretty high voltage. So this guy is powerful now. And we still have incredible range. And I could probably move that halfway through my house. I ground it, it'll light up. And as you can see, I can crank this thing to 60 volts, no problem. And it will use probably almost 100 watts. 83 watts. 82 watts. And it just got incredible in here. That is ridiculously bright down there. That is, I mean, for such a small device outputting such power, I'll shut that light off and show you. Like, look at that. And the range, too. I can probably even further improve the range. I don't think a device this simple, small, and powerful exists anywhere on YouTube or the open market. You'd probably have to pay crazy money for it if it does exist. And I'm probably thinking of selling this once it's perfected for maybe $200 or $300, maybe $150, anywhere from $150 to $300, depending on the power output model. And it's going to be called M-Tech Technologies, a true solid-state Tesla coil. It runs on DC pulse, no AC, none of that crap. Solid DC pulse. So it's consuming 60 volts at 1 amp, stabilized at 76 watts. It just shows you I can really crank it if I want to play with it. Yeah, we're going to put it back down to much more safer levels. I usually play with it at about 30 for two. I play with it at 30 for fine testing. Good enough. 30 watts. 30.6, almost 31. Still a pretty decent amount of power. A little more sensitive to tuning at the lower voltage, but range is still good. Those are lit up. Still very bright. Have to work out a few more slight resistor values. So he runs best at about 35. Might have to put like a 10K resistor on the base of the transistor. Because this transistor is very current hungry. See how it goes out like that? Something isn't quite tuned. I have a feeling it's the resistor, but like I said, I'm still messing around with this thing. It's almost a finished product, and when it is, it's going to be sold as kits. The most simple, solid-state, real Tesla coils that you can do ground energy experiments with too, and you can undoubtedly extract more power out of the ground with it once you ground it. So, ungrounded gets dimmer. Ground it gets much brighter. I mean, I can show that effect right here. Ground wire. Literally the ground wire. I connect the ground wire to the middle and boom. See? It's acting as an energy pump. No ground, ground. No ground, ground. Cool stuff, huh? It's acting as an energy pump from the ground. So let's connect it back up. And yeah, here it is. I think the top load should be more mushroom or donut shaped, and it would really extend the range. And these fluorescent tubes are like burning in my hand. Hi.